So then we're going to look at some different ways, different algorithms for machine learning. So this is a random grouping of data that we've set up. And the first one we're going to look at is Cambridge's neighbor. So what you do, in this one we have a new data point and we want to figure out what class we should classify it as. So we look at its 3 nearest neighbors, and in this case they're all green, so we classify it as green. With this one, its 2 nearest neighbors are blue. There's a green one, but since a majority of them are blue, we're going to classify it as blue. So Cambridge's neighbor gives you a nice line between your data to classify things, and it classifies them pretty well. You need a lot of data is one of the issues with this. So you need a lot of training data. And then our next one is linear discriminant data analysis. So with this one you need normally distributed data. So what you do is you find the mean of your data, and then you find the distance out from where your data would be. And then you can find a new data point and you can just see which mean it's closest to. And this gives you really accurate lines showing which class to classify your data as, but you do need normally distributed data. And then this algorithm is a classification tree. So what you do with this one is you have your start and our data, and then you take a feature of your data, so in this case the roughness of it, and you have a decision. Is it bigger or smaller than A? And we're going to classify things that are bigger than A as vegetation, as green, and then we take another feature and we split the data again, and we get the cars and buildings classifications. So you'll see we have this dot here, which is green, but it's actually classified as blue. We don't really care if there's a point that's not in the right classification. We just kind of want to get the majority of points in the right one. But the problem is that our real data looks like this, so it's not quite as easy as that. So what we're going to do is we're going to do a random forest. So for a random forest, what we're going to do is we're going to take a random subset of our data called in the bag sample, and the stuff left to back is the out of bag sample. And then we're going to take a random bunch of our features, and we're going to make a tree, just like we did before. And then because we're going to make more trees, and because they're random, they're all going to be kind of different, have little different splits and different features. And then you do this a bunch of times, and you get something that kind of looks like that, but you get different trees, and then what you'll do is you'll run your data through it, and then whatever your data gets classified most often as is what you'll classify your data as. So then these are the classes that we used. So this is the ground truth, and we have 3 types of vegetation. We have forest, landscape, trees, and landscape bushes. 3 types of buildings. So we have buildings, townhouses 1 and townhouses 2. 2 lights, street lights and tall lamps. Cars and people are also very similar. And then roads and sports turf. And again, those are all pretty similar. So we're getting kind of down to the pretty nitpicky differences. And that's the landscape bushes. It's kind of hard to see on the other one. So if we look at this line going across our data, and then we have plotted the LIDAR data for it, and we have the max, the mean, and the min heights, you can look and you can see where the building, the max and the mean are fairly, the max and the mean and the min are all very similar. Where you can see the trees, the max and the min are quite different. So you can use this to kind of define